Okay, so position is where you are at a certain time. Velocity is the first derivative of position. So if position, sometimes position is called s of t, we're going to call velocity s prime of t. It's how fast you're going at a certain time with positives and negatives based on the direction. Acceleration is called the second derivative. So if you have position and you want to find velocity, velocity is the first derivative. If you want to find acceleration, you take the derivative of velocity, which means the second derivative of position. And we've not really been doing second derivatives, but that you can. Yeah. You can do as many derivatives as you want. And so we know what the first and second are. They're really important. Okay? So here's an example. We have Bugs Bunny here. And this is the height after t seconds of the shot that's made. Okay? So this is a height, which means this is position. And the question wants me to find velocity and acceleration and then explain the meaning. So if I'm going to find velocity, I'm just going to take the derivative of the position. I'm going to have to multiply. So I've got to do 2 times negative 2.66, which is negative 5.32 t plus 135. That's velocity. If that's all it asks you, just find the velocity. You just find the first derivative. Alright? It also says find acceleration. And so acceleration is the second derivative. I just take the derivative one more time. And so that's acceleration. Okay, so what's the position of the shot when the velocity is 0? Okay? Position means where is it at when the velocity is 0. And to figure that out, we've got to figure out when the velocity is 0. Okay? So we know this is velocity. So we're going to set this equation equal to 0. And solve for t. Because t is going to tell me the time whenever the velocity is 0. So you subtract 135 and then divide by negative 5.32. And I get 25.375. I'm going to round to 3 places or go to 3 places because that's what you would do in AP. That's the time when the velocity is 0. Okay? But that doesn't tell me the position. To find the position, I have to take that time and plug it into the s of t equation. So we would have s of that value, which means that's what I'm going to plug in for t up here. And I'm just plugging it into the calculator. So negative 2.66 times, and I'm going to use that whole value squared. If you don't use the whole value, it will round it weird. So you need to use the whole value. So just plug in that in the calculator and I get that. Now, because this is velocity and acceleration, a lot of times there's units. So let's go back and look at the units here. It tells me that the height is in feet and then t was in seconds. So it was at 25 seconds whenever the velocity was 0. And this means this is the height at that time. So this is 1715.875 feet. Okay, when the blank is positive, the object is moving in a positive direction. So that means when the velocity is positive. So if you get a positive answer for velocity when you plug in a certain time, that means that you're moving in a positive direction. Usually it's up or to the right. It just depends on the situation. Okay? An object is blank when the velocity and acceleration have different signs. This has to do with speed and all kinds of different things, but we're just going to say slowing down for right now. An object is stopped when the velocity is 0. So if you drive to school in the mornings and your car is parked in the parking lot, when you park, the velocity would be 0. And then when you leave, you're going to move again, so velocity is no longer 0. So velocity is 0 when the object is stopped. Speed is always positive because it is the absolute value of velocity. So if you know the velocity at a certain time, then you actually know the speed because you're just going to take the absolute value of it. And so here's an example about that. So a bug begins to crawl up a vertical wire at time equals 0. The velocity of the bug is this graph right here. So this graph is telling me how fast the bug is moving. Okay? At what value of t does the bug change directions? Okay? Remember, this is velocity. So if the velocity is positive, it's going up the chain, even if the velocity is going down. And then once it changes to negative, that's where the velocity starts moving the other direction. So where's the velocity going to change directions? 6. Because 6 is the only time it changes from positive to negative. Because velocity is positive here, and then velocity is negative here. We have to be really, really careful when we look at these graphs because this is a velocity graph. And if you have a velocity graph, you don't think, oh, it's going up and then it's stopping and it's going down, because this represents velocity. If I want to know what's the velocity at 2, it's 3. The velocity at 3 is 3. It just means that that's how fast it's moving at that time. It's not stopping even though it's flat, because this represents velocity. Okay? During which time is the bug slowing down? Alright, whenever I try to think about slowing down, basically I think about the speed, and I think about when it's the actual, looking at velocity and speed and when it's going down like that. Now, because velocity, it's underneath the x-axis right here, what I'm going to do is I'm going to draw the speed graph, because speed will help me figure out the slowing down. The speed graph is the absolute value of velocity, so any parts that are negative are going to come up. So speed is the same as velocity at first until 6, and then speed does this. This down here is velocity, the orange represents speed. If you find the speed graph, the bug is slowing down where the speed is decreasing. Okay? So speed, it's going up. It's a constant speed. It's going down here. So this is a time where it's slowing down. So 4 to 6. Speeding back up again here. And then it's slowing down here. So 7 to 8. And these are intervals. That's not x's and y's. Those are just intervals to represent that. Okay. Again, this graph is velocity, so be really, really careful. When you're looking at the graphs, make sure you know what kind of graph you're looking at. It is velocity. It tells me it's velocity here, but it also labels it as velocity. So when is the particle moving to the right? Okay, let's think. Moving to the right is when velocity is positive. So velocity is positive. All right, is this velocity positive or negative?
Negative.
It's negative all the way to 4 because it's below the x-axis. So velocity is positive all up there because that's above the x-axis. So it's positive from 4 to 10. And I'm putting parentheses because at the endpoints things are changing and we don't know really, so I'm just putting parentheses. When is the particle moving to the left? So if this is all positive, this would be the left part. This would be the negative, and that would be 0 to 4. And I'm writing why because I think that will help you understand later if you're looking at your notes. It says, when is the particle stopped? Okay, particle stops when the velocity is 0. So when's the velocity 0? When does it touch the x-axis? 4. Alright, we're talking about speeding up in D. We're also talking about slowing down in F. That means that I need to draw the speed graph, which means anything below the x-axis needs to come up. And I'm just flipping it up is all I'm doing. So it's that orange plus all of this other part that's above the x-axis. Alright, it says speeding up. So speeding up would just mean going up on the speed graph. So 0 to 1. This is constant speed. This is slowing down. I'm going to go ahead and write the slowing down here on the slowing down part. So that's at 3 to 4. Okay, speeding up again was 4 to 5. Slowing down, I'm just doing it parts at a time, so 5 to 7. Speeding up 7 to 9. Slowing down 9 to 10. Alright, then it says when is the particle change direction? So the particle is going to change direction where the velocity changes from negative to positive. Also the place where the particle stops, so that's still at t equals 4. Alright, next it asks about acceleration. Remember that acceleration is the second derivative. Okay, this is velocity. This is the first derivative. Okay? Acceleration would be the derivative of this graph. If I want the acceleration to be positive, that means I want this graph to have a positive slope. So the slope here is negative. The slope is 0. The slope is positive from there to there. Negative and positive. So where the pink is, that's where acceleration would be positive, because that's where the slope of velocity is positive. And so that would be from 3 to 5, and then also from 7 to 9. Then it asked me, where is the particle moving at the greatest speed? Remember that the speed was that orange graph that we drew? And so for the speed to be the greatest, I'm wanting the highest y value. And so where's the highest y value here? On the orange. It would be up here. That's where it's the highest. And so it's actually from 1 to 3. What is the particle moving at its greatest speed? Okay, the when would be from 1 to 3, and the actual speed would be 4. And when is the particle's acceleration negative? So that would be not the pink, and also not where it's flat. So acceleration again is slope. So acceleration being negative would be here and here. So that would be from 0 to 1, and then also 5 to 7. Oh, and also 9 to 10, thank you. Because it's going down there as well. Alright, so if you want the average velocity of a particle, when you see the words average velocity, that's representing the slope of the secant line. So you must find the slope between the 2 points. Average velocity is the same as average rate of change. If you want velocity of a particle, you must find the derivative. At t equals 4.